Okay, so this current video that I'm going to do now over what the zero of a polynomial is not going to, at first it won't seem like it has any connection to how you divide polynomials. Whether you use long division, which I showed you, or synthetic division, which I also showed you. My point of showing you that was to address this topic and go a little bit further in the assignments, okay? So the connection might not seem obvious at first. It might take you thinking about it a little bit. You might get frustrated, but I guess that's part of the learning process, and you have to practice and ask questions, right? Okay, so let's get to it. Question is, what is a zero? Where of everything you see there, it's like the zero, that word, that's my vocabulary word. What is a zero of a polynomial? So here I give you a polynomial, and I tell you that x minus 2 is a zero of that. It won't surprise you that all I'm trying to say is if you plug in negative 2 into that function, then you get 0 as an answer, okay? In other words, like for all functions, we put a number in, and then we do the calculations, we get something back out. A 0 is just something that gives you an output of 0, okay? Let's see, is that true? Let's verify it. I get negative 2 squared, okay, plus 5 times negative 2 plus 6. Okay, that would be me making negative 2 the input to that. And now we do the math. What's negative 2 squared is 4. What's 5 times negative 2? Negative 10 plus 6. And 4 minus 10 is negative 6. Plus 6 is in fact 0. Okay, so that's all I was saying when I said negative 2 is a zero of that polynomial. If negative 2 goes in, 0 is what you get back out. Okay? All right, so that's just a definition, just basic definition. Here's where we take it a little bit further. Okay? When we have polynomials, zeros will result from there being related factors. Okay? And that is true on its own. But if you just read that, you'll probably have no idea what that says, okay? So here's what I'm going to do. I'll show you through an example. I got this same function up there where negative 2 is a zero of it. But the fact that negative 2 is a zero of that comes from it factoring in a specific way. All right, so I want you to connect like factors and zeros in your mind. So watch, take that. Could you factor it? Is it possible? Think about it for a second. Can you take that and do like something like this? I mean, what do we mean when we factor anything? Like, say you're in elementary school and you say, can you factor 20? You could say 4 times 5. You could say 2 times 2 times 5. You get the idea. All right, so I'm just saying, can we do something like that here? Well, yes. Factoring is something that you have to learn how to do. If you don't know how to do it, we can talk about it, but it's x plus 2, x plus 3. Okay, that will in fact multiply to get you this. Factoring is the reverse of multiplication. So do you see how zeros and factors are connected? X plus 2 says negative 2 is a 0. Why is that? Well, what if you plugged in negative 2 into this? What's negative 2 plus 2? It's 0. And what's 0 times whatever that is? 0. 0 is going to be the output. Is there another 0 of this function? Negative 3. So let's connect them together. Zeros will come from factors, and mentally we'll see that they're just two sides of the same coin. So I'm going to say I'll say like this. So you see, we factored it right there. We had some function that we started with. We factored it, and I look at that, and it says x plus 2. This says negative 2 is a 0. of that function, or of that polynomial. And then I look at this other one, and it says negative 3 is also a 0. Okay? And if you don't believe me, then you can take either of these inputs, plug them into that original function, and see that 0 is the output. But I can, if it's factored, I can just tell that those numbers are going to be zeros. Okay? It's the opposite of whatever that and that is. Okay, so that's how we need to connect things. That's how we need to think about it. All right? Now, okay, so where do we go from here? If you do the assignments, there will be questions where it says, can you solve the equation? And can you solve the equation? And it seems to give you like a kind of a hint about it, okay? And we'll talk now about how to do those. So this one, well, okay, you won't find anything that simple in the My Math Lab assignments or in the book at this point. But the way you do this one, even though it's easier than that one, is not too much different. I mean, this is just a harder version of this, okay? So how would you solve something like that? X squared plus 5x plus 6. You would solve it by factoring, okay? So let's say like for something that complicated that has a higher power in it, like a square, then the method that we use is to factor it and get the answers from there. So I can say, all right, yes, I can factor that. It's x plus 2 times x plus 3. And if those two things are going to multiply to be 0, then either one of them being 0 would give me an answer. And so my solutions are that negative 2 is an answer from this factor, and negative 3 is an answer from that factor. So that's how we would do it. In other words, it's a lot like what I just showed you over here. That when I factored it, I got numbers that if you plug them back in would make it be a 0, okay? Now, if I'm going to solve this bigger, more complicated problem, I would do it the same way, which is I would do it by factoring. But that's like way, I mean, for most people, that's too big and complicated to factor. All right, so we need some kind of a hint. So here's the way it's going to look in the book. If you're doing the My Math Lab, here's the way it's going to look on My Math Lab. It'll say solve this big equation, and then they give us a hint. They'll say, given that 2 is a 0 of that polynomial. Okay? So given that if you plugged in 2 into that, you get 0. So another way, it's like saying, solve this equation, here's your hint. 2 is an answer to it. Okay? All right. Now, so here's how we go from there. If 2 is a 0, what do we say? Didn't we say zeros and factors are the same thing? That means that there's a factor that gives you that. Okay? And then if we can divide it out from there, or dividing. Did we talk about dividing? Yeah, we talked about dividing. If you divide it, you should get a 0 remainder. Okay? That's the way it should work if that is a 0 of the function. That means that there's a factor that comes from that divides us perfectly. So, all right, let's do like this. Let's say here's where we take the thought process. So that's the hint. Okay, thought process. If x is 2 is a 0 of that polynomial, then x minus 2 would be the factor that gives you that answer. Okay? Now, if that's one of the factors, what are the rest of them? Okay? Well, that's where we divide. So let's say I read this, and I say, okay, well, there's this factor that comes out of that. But what's the rest of it? Well, then we divide. Okay? We divide by x minus 2. We divide x minus 2 into this thing, however you want to do it. Okay? Now, I showed you different ways you could divide. I think most people would just use synthetic division, so let's set it up like that. I'm going to divide x minus 2 into that big gigantic thing up there. What was the setup for that? Put a 2 here. All right. What's that mean? It means I'm going to divide by x minus 2. And I'm going to divide into all that, which is 1x to the third, 2x squared, minus 5x minus 6. And then we put our line. Okay? And then if we want to be real careful, we write some things down in red ink to keep track of it. This says I got 1x to the third, okay, 2x squared minus 5x minus 6, okay? All right, what was the procedure from there? Bring down the 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 5 and 8 is 3. And 2 times 3 is 6. Negative 6 and 6 is 0. Okay, is that the way we expect it to work out? No remainder? Yeah, no remainder at all. I mean, if 2 is a answer to that, then x minus 2 is a factor. Okay? If negative 2 is an answer to this one, then x plus 2 is a factor. All right, so no remainder. What's the rest of this? Those are paired with x's one less in power than what you see up there. So x squared, x, and number, and all that's the quotient. Okay, now here's what that's going to tell us. It will tell us that the way that original equation factors is to be x minus 2 times x squared plus 4x plus 3. Okay, that's what it means. So let's say this. Now we were able to factor that one time. X minus 2, x squared plus 4x plus 3. Okay. So with that hint, I was able to take this big gigantic equation I'm trying to solve and factor it one time. Like factor x minus 2 out of it. And then that's the rest of it. Okay? All right. So we get there now. The idea would be to get all the answers. So now I look and say, okay, can I break it down any further? Can I factor this thing right there, x squared plus 4x plus 3? And I can take it a little further. X plus 3, x plus 1. Okay, that's correct. And I've now broken it down as much as I can. Okay, I've factored it into the most reducible pieces. I can't go any further. And every factor gives me an answer. Okay, what answer does this one give you? 2. And what does that one give you? Negative 3. And that one gives you negative 1. Okay, so here's our complete solution. All our answers that that equation can have, it's 2, which I get from here, negative 3, which I get from here, and negative 1. Okay. Can we check it? Yeah, plug them in to that, they work. Guarantee it. Okay? All right. Now that's the procedure. That's how we use division. That's how we use this hint and division to ultimately factor and get answers. Okay? Look back at this one. Is it really any different? No, it's like factoring is how you got the answer. But when you get something a lot bigger than this one, well, for now at least, we need some kind of hint on how do you start factoring it. And then the division takes care of it from there. Okay? All right. Now I can give one more, an analogy to this. Okay? And it's sort of like saying, like, suppose you had to factor 100. Okay? And suppose you didn't know how to factor 100. And I said, here's a hint. 2 goes into 100. All right, you say, okay, well, that'll get me started. I can get my calculator, I divide 2 into 100, and it says 2 times 50. And that kind of gets the ball rolling, okay? And then you just keep going from there. 2 times 5 times 10. All right, and then you can go further. You can say 2 times 5 times 2 times 5. But if you don't know how to factor 100, maybe I give you a hint, and that just gets things going. You divide to figure out what that other number is, and then you could keep factoring. It's a lot like that. What we do here is a lot like how I just described that one. Okay, so let's do this. I want to show you how to do that type of problem, which you will definitely see in the My Math Lab assignments. And I wanted to give you another one. And just have it be like that. If you wanted to, you could try to do this one the same way I did the last one and see if you can get the answer. You can pause the video and you can try to do it yourself, all right? Or if you just want to see another example to pair with that one to help you with the assignment, then that's what this is going to be. So either way, I'm going to leave it up to you. Okay, so I have a kind of a big equation that I'm trying to solve, and I'm given a hint about what one of the answers is. So let's go through that same thought process. Okay, so I read this here as basically saying that 1 is an answer to that, okay? And I interpret that this way. It says that x minus 1 is definitely a factor of that big gigantic equation, okay? All right, so that's my thought process. But if it's a factor, then I'll do some dividing to figure out what the rest of it is going to be, you know? It's like take 100. Say you're supposed to factor 100. You don't know how, and I say here's a hint. 2 is one of the factors. And then you divide 2 and 100, you say 50 is the rest of it. It's going to be like that, okay? So now we'll divide. And what's that going to look like if we divide x minus 1 into all that? And you divide it any way you want, long division or synthetic division, just divide it, all right? Well, if I'm going to divide by x minus 1, I put a 1 in this box, and that says I'm going to divide, as stated, by x minus 1, and then I'm going to divide into that, okay, which is a 1x to the third minus 13x squared plus 47x minus 35. And of course, if you practice this, maybe you get so good at it you don't even think about it. But if you like to be careful, then maybe you get your red pen out and you say, I got here 1x to the third negative 13x squared, 47x, and 35 in order, all terms accounted for. Okay. All right. Anyway, so let's see. What was the procedure for synthetic division? Bring down the 1. Always just immediately bring this first number down, then multiply it by that one. I get 1. I'll get negative 12. Negative 13 and 1. I'll multiply. I'll get negative 12 here. Okay. I'll get 35. 47 minus 12. And then I'll get 35 here. And then I get 0. And you'd say, yeah, 0 would have to be the remainder. If I say factor 100 and I say hint 2 is one of the factors, well, 2 better go into 100 without a remainder. So yeah, I mean, you would expect that to be a 0. Okay? All right, so that's going to be our remainder. And then what's those numbers? How do we interpret that? 1x squared minus 12x plus 35. That's the quotient. Or that's the rest of it when you factor it. Okay? All right. So here's how we read this. We'd say, started with that equation up there. Here's what I have now. All right? Here's what I have now. I have that is x minus 1 times x squared minus 12x plus 35. Okay, that's what it says. That's the result of this being a hint about that as an answer. And here's the factor that would give you the answer. And by dividing it, I find what the rest of the equation should be. All right, just like the other one. Okay, all right, what next? What next? Well, to get all the solutions, I have to break this down into simplest and smallest parts. And from every little piece, I get an answer. So I look at that and say, well, does that break down or factor any further? And I think it does. So my factoring on x squared minus 12x plus 35, that'll be x minus 5, x minus 7. And as I said before, we can do a whole video on factoring if you want to or need to. But that is, a matter of fact, that's how you factor that. Okay? Now it's broken into smallest parts. There's no way I can factor it anymore. Look at each little piece of this. Each little piece gives you an answer. That says that 1 is a solution. This one says that 5 is a solution. And that one says that 7 is a solution. So there's all the answers to that thing up there. 1, 5, and 7. Okay? Now maybe I'm taking a little bit for granted how you connect them, but you know what? For example, why is 7 a solution? Well, say you plug 7 in up here. What's 7 minus 7? 0. And what would 0 times all this other stuff be? 0. If you took this number and put it up there all the way across, it would work. Okay? All right. But as I had said at one point, make the connection that a 0 comes from a factor. And you kind of think of them as the same thing in your mind. Okay.